Welcome to ACT Prep Day 37. Everybody should have your bell ringer book out and flip to the yellow page, Day 37. So today you've got functions. Remember, a function, for every x, there is only one y. And so here you've got different sets of functions. And so like for the first one, they want you to take that function and then solve for f of -2. So take a few minutes, pause the video, work on the bell ringer, and when you're done, then unpause and we will go over the answers. Okay, welcome back. Let's check these answers here. So if you look at the first one, it's got f of -2. So that basically means everywhere you see an x in this function, we're going to replace it with a -2. So 6 times -2 gives us -12 plus a -3 gives us -15. And then over here, same thing. Everywhere you see an x, we replace it with a -1. So you're going to get +1 plus -4 minus 1 gives us -3. Oh, sorry. Yeah, but yeah, -3. Sorry, I confused myself for a minute. Then over here, we have an f of x and a g of x, and they want to know what is f of g of 5. So we need to solve f or g of 5 first. So we replace everywhere we see an x with a 5. 5 minus 2 is 3. So now we've got f of 3 because g of 5 equals 3. And so we just go up here to f of x, and everywhere we see an x, we replace it with a 3. And so 3 plus 3 is 6. And we come over here and we do the same thing. We solve for f or for g of -4 first. And -4 times a negative gives us positive. So g of x is 7. And then we plug in here 9 times x is 63 plus 2 gives us 65. Okay, so more geometry today. Angles, Pythagorean theorem, and similar triangles. Yes, so an angle is formed by two lines or rays. And the point of intersection of those two lines or rays, we've got an angle. That's where the vertex is, where they come together. Figures contain angles if we've got polygons. You might have questions on the test related to the relationships of the angles in the figures. Like I always love when two lines intersect, they form a linear pair, or my favorite, vertical angles. If you have a triangle, you should have memorized, they expect you to know that all three interior angles in a triangle are going to add up to 180. So if you know the measure of 2, you just subtract those from 180 and you get the third one. You need to make sure that you know about parallel lines and transversals. The 4 angles in a trapezoid, you should know they all add up. If it's a 4-sided figure, they all add up to be 360 degrees. Here you've got an isosceles trapezoid. And if it's an isosceles trapezoid, you can see base angles are congruent. Same side interior are going to be supplementary. Now, Pythagorean theorem. This is probably one of the biggest theorems in geometry and even in math. Not only has Pythagoras proved it, he was the first one to prove it, but it's been proven 3 times. You got Pythagoras, somebody else, I'll be honest, I can't remember. But I've always remembered that one of our sitting presidents proved the Pythagorean theorem. It's been proven 3 different ways. And when I mean sitting president, it means while he was in office. It's not like he was on retirement or before he was president. While he was in office as the president of the United States, he actually proved the Pythagorean theorem a different way. And it was James A. Garfield. Yeah. What else do you attribute to James A. Garfield? Not much. I don't know what he did in his presidency, but he did prove the Pythagorean theorem a third different way. Yeah. And so this basically is the fundamental relationship between the 3 sides of a right triangle. And you're probably going, yes, that's a squared plus b squared equals c squared. Yes. And in a right triangle, we have two legs and a hypotenuse. And the hypotenuse is always the longest side, or the side that's opposite the 90-degree angle. And the legs are the two sides that actually create that 90-degree angle. And so the theorem is, as I stated, a squared plus b squared equals c squared, whereas c is the hypotenuse. And you can see it in the figure here. We've got a and b are the legs. C is the hypotenuse. It's always opposite the right angle, and it's always going to be the longest side. And a squared plus b squared is c squared. And anytime I see a right triangle, that's the first thing that comes to mind is, ooh, maybe I can use the Pythagorean theorem on this. And most students always tell me the hypotenuse is longer than either of the other two sides. And if you know this, again, ACT is a multiple choice test. So sometimes that can help you eliminate possibilities, especially if they give you the length of the two legs. And, you know, one of the leg length, the larger of the two leg lengths is 9, then you know the answer for the hypotenuse has to be greater than 9. So you can eliminate anything that's less than that. You can use this when you need to determine the unknown side lengths of a right triangle. See if it'll help. A lot of times it will help you if you just by knowing that the hypotenuse is the longer side. Now, similar triangles, okay? This is really cool. You had this in geometry as well. Triangles are similar if their corresponding sides are in proportion and the corresponding angles are congruent, okay? Like here, we've got these two right triangles, and you can see they each have a 90-degree angle. Here we've got this angle congruent, and we could prove by the third angle theorem that these two angles are congruent. We could actually prove these two triangles are congruent, are similar by angle. And we've got here, the sides are in proportion. These sides, the one that's on the left, they are twice as big as the one on the right. So they are similar. And actually, the whole branch of math, trigonometry, is based on similar right triangles. Yeah, they have a 2-to-1 ratio. The one on the left is twice as big as the one on the right. Yep. Or you could say the one on the right is half the size of the one on the left. Now, sometimes when you're looking at similar triangles, they could be like the ones before, they were orientated the same, or you could have one that's rotated. It could be flipped and turned and all kinds of different things. Some people can see that really easy. Other people can't. It takes a little bit longer. And so on a time test, that can be harder if it takes you a little bit longer. That's where all those like tick marks and arcs can kind of come in handy. So like for me on this one, the arc marks really come in handy here because I'll be like, okay, here's the one with the 2 arc marks. It goes over here with this one. And then here's the single one. So it looks like that second one just needs to be tilted this way, and then they're equal. And so that means this 10 goes with the X, this 7 goes with the 14, and this 6 goes with the 12. Okay, so it looks like the one on the right is half the length of the one on the left. So if 10 goes with X, then that means X must be 20 because it's twice as much. Now let's look at our ACT example. What is the length of the legs of an isosceles right triangle with a hypotenuse of 9 units? Wow, we've had this one before. Because I bet many of you are doing Pythagorean theorem. And how many of you are going, oh, there's a way Edwards did it. And she said, like, she barely had to pick up her pencil and she already knew the answer. Yes. Because it was what? Yes, it's trig. Yeah. All right, so let's see how the book does it. I already know the answer to this one. It's D. Yeah, it's D. I wouldn't even have to pick my pencil up. Okay. Because this is probably how you did. Probably drew a right triangle. You know the hypotenuse is 9, so that means the legs. It's isosceles, so the legs are the same. They're x and x. And you did x squared plus x squared equals 9 squared. 2x squared equals 81 divided by 2 Take the square root. Get 9 over the square root of 2. Can't have square root in the bottom. So we multiply top and bottom by square root of 2 over square root of 2. And we get 9 square root of 2 over 2. Yeah, that takes a lot of time. I'm lazy, but I like to get my answers right. So when I learned trig, I memorized it. And I know that this triangle has the relationship of 1 square root of 2. So if these have a length of 1, this has a length of square root of 2. So if this has a length of 9, I know that this side here is going to be 9 divided by the square root of 2. Yeah. So it just wants the length of a leg. And look, this is what we got right here after the Pythagorean theorem, 9 divided by the square root of 2. And I did it instantly, 9 divided by the square root of 2. And then I know can't have the square root of 2 on the bottom, so I basically move that to the top, take away the radical. My answer is D. Yeah. So there's sometimes, like when you get to math, a lot of the things in math, somebody figured out because they're just like me. They want the answer correct, but they're lazy. And they're like, why do I want to go the long way around and do this long way every time when there's a shortcut there where I can figure it out a whole lot faster? Is it really being lazy or is it being smart? Working smarter, not harder. That's called efficient. That's efficient. Okay, so let's do, how do I get out of the pen? There we go. Okay, so 5 questions today. Set your stopwatch, your timer on your computer, on your phone, whatever you got. Set it for 5 minutes right now. Then you hit start, pause the video, and get back to me when you're done, and we'll go over the answers. Okay, ready, set, go. Okay, well, welcome back. And let's go over these 5 questions. Let's look at the first one. In the figure below, angle ACD measures 112. Okay, I always like when I'm in geometry, I write on everything. Why? I'm visual. I like to see it. When I see it, it like pops out more. It's like it screams at me like, hey, this is how you solve me. BAC, ooh, right up here. This one is 40 degrees, okay? And it says that points B, C, and D are collinear because if they're not all on the line, that can make a difference. And they want to know what is this measure right here. Okay, so I put my little question mark there. There's several different ways I can go with this, quite honestly. I can say these two are a linear pair and find the measure here, and then do the triangle angle sum theorem that these 3 all equal 180. Or there's a faster way I could go. There is the theorem that says, the exterior angle theorem, that these 2 angles added together equal this one. That's a little bit faster. It's 1 step faster. So if I do 112 minus 40, what do I get? 72. Yep. So this one is 72 degrees. Yep. Number 2, here we've got the measure of CAD. This one is what? 6x plus 10. And the measure of BAD, the whole thing is 90 degrees. They want to know what is the measure of BAC. Okay, well, that's going to simply be 90 minus 6x minus 10. It's kind of hard to write in PowerPoint. And so then you get 90 minus 6x. A minus times a minus is plus 10. And so we have 100 minus 6x. So the answer is what? Wait a minute. Oh, did y'all see what I did wrong? Caught you there, hopefully. This is a plus here, so this, oh my gosh. Yeah. I could lie right now and say I was trying to trip you up, see if you caught my mistake. Yeah, no, I totally botched that. Let's just be real here. No, so then that should be a negative times a positive should be a negative. So that should be a plus. Yeah. Totally botched all of that. Oh, yeah, totally botched it. So then that should be 90 minus 10 is going to give you the 80 minus 6x. Gosh, Edwards, yeah, y'all might catch me on stuff. Haha. Hey, just goes to show teachers make mistakes. Yep. Teachers, we do make mistakes even on our best days. That's why you double check. 3, for triangle ABC, which of the following is an expression for x in terms of y? So x in terms of y is going to be where you go like x equals, and whatever's out here is going to have y in it. So right triangle, Pythagorean theorem. So you're going to have x squared plus y squared equals 12 squared. So we'll get x squared equals negative y squared plus 12 squared is 144. You should know your perfect squares. And so then when we take the square root of it, we're going to get x equals, and I've kind of looked over at the answers here because it like negative y squared. You don't really see it. Looks like they flip-flop these two. Is the square root of 144 minus y squared. Yeah. So it looks like it's D. Mm-hmm. And then here, what is the length in inches of the hypotenuse of right triangles with legs that are 7 and 10 feet? I'm probably going to draw it. 7, 10. You don't have to. And it's really just going to be 7 squared plus 10 squared equals c squared. So you've got 49 plus 100. It's going to give you 149. And you take the square root of it. Hey, and it's right there. Square root of 149. Obviously, you can't simplify that anymore. Yep. And the very last one. Here we've got similar triangles. So we've got DE is parallel to AC. DE is perpendicular to CB at E. The length of AB we've got is 26 units. The length of DE is 5. And the length of BE is 12 units. What is the length in units of AC? So this one can be a little bit tricky here because we need to know, honestly, we need to know this length right here. Okay, we need to know that one. And we don't. So we can use Pythagorean theorem here, though. You've got 5 squared plus 12 squared equals the hypotenuse squared. I think this is a 5, 12, 13. 25 squared plus, what is 12 squared? 144. Why am I going blank on 12 squared? 121. What is 12 squared? Oh my gosh. Why am I having to pick out my calculator for this? I'm going to feel really stupid when I do it. Am I not? 12 times 12. Yeah, 144. Oh my gosh. Okay, I'm recording this and it is 250. That's why, yeah. So then we get this and we end up getting 169. You do the square root of that and it is 13. This is one of your Pythagorean triples. It's a 5, 12, 13. And if you have those memorized, it helps. And I said at the beginning, I thought this was 13. So now what we can do is we can set this up. We can say that 13 is to 5. The hypotenuse is to the base. Hypotenuse is to the base as the hypotenuse of the big triangle, 26, is to the base. And you can almost look at it and see it's doubled, so x is going to be 10. Yeah. Yep. All right, so your exit ticket on this one. The exit ticket for day 37 is, given the relationship between the sides of a right triangle where A and B are the legs and C is the hypotenuse. What is the relationship between the legs, A and B, and C, the hypotenuse? We talked about it. It's been proven 3 times, and 1 time by a sitting US president. It also has the name of a famous cat that used to eat lasagna. Yeah, and might be giving my age away because you might be going, huh, what cat that ate lasagna? It was a cartoon cat. But yes, I've talked about it throughout this lesson. Anytime you see a right triangle, you should be thinking of this theorem. So that's what I'm asking for in the exit ticket. So I hope you enjoyed the lesson and fill out your exit ticket, and I will see you tomorrow.